So the first concept I'm going to cover is kind of obvious. It's how we can organize our resources into hierarchies, and then how we can use those hierarchies to federate out access. We touched a little bit on this in the primer video, but we're just going to go through a few examples here to make sure that we really understand the concept. So switching over to back to Excalidraw, my favorite diagramming tool, we can look at one of the models that we set up last time, where we have a document, and then the document has a reader and an owner, and the type of that reader and the owner is a user. It's very uncommon to have just a flat document structure where you just have readers and owners. Usually documents are organized into some kind of hierarchy. So what we're going to go ahead and do is we're going to start setting up a little hierarchy here. So a document will sometimes belong to a folder, or often belong to something called a folder or directory. And then that folder often belongs to like a drive, a top level concept of a drive. You can see this in like Google Drive, or even if you talk about like a Windows machine, you've got like your C drives, or on Linux machines and Unix machines, you've got your mounts. So we have this kind of hierarchy. And then the way this works for permissions is we'll go ahead and set up a relation in the hierarchy as well. So we'll set up, we'll say that a document has a parent of a folder. And then we can also say that the folder has the parent of the drive. Running a little short on room here, but just kind of squeeze these in. And then the interesting thing that we can do once we have this hierarchy is we can actually replicate what we've already established as a permissions model. We can replicate that for the higher level objects. So we can say that a folder also can have a reader or an owner, right? So a reader, and that's of type user. And then the folder can have an owner, and that's of type user. And then we can also say that the top level drive itself can have a reader or an owner. And same types on everything. So what we've done here is we've established the ability to federate out permissions at any layer in the hierarchy. And switching over to the playground, we can see what that looks like in schema. So we've got definition folder, drive, and we're going to say that a folder can have a parent of type drive, and a drive can have a parent of type, sorry, not a drive. A document can have a parent of type folder. And then if we want to see how we can use this to federate out permissions, we can say that the document can have a permission called view. And the permission view on a document obviously takes into account the reader and the owner, but it also takes into account a parent reader or the parent owner. Now, another way to model this would be to give the parent a permission. So we could say, we also need the reader and the owner here. So we could say that the permission view on a folder is calculated by saying reader plus owner. And then down here, we would just say parent view. Permission. You'd think by now I'd be able to accurately type the word permission, having done it several thousand times. Okay, so now we're inheriting the view permission from our parent, and our parent in this case happens to be a folder. But we want this to actually cascade all the way up to a drive. In this case, let's give a drive a slightly different schema. We'll say a drive doesn't actually have, like, you can't have a reader at the root level drive. So we'll go ahead and change the model. I don't know, like, this is going to be totally use case dependent, but we'll just say in this model, a drive can only have one owner. So now we'll say that this is reader plus owner plus our parent's owner. And so now we've set up a model where base level view on the document can come from directly that document's readers or owner, or it can come from the parent, those who have the view permission on the parent. In this case, the parent's view permission is going to be that folder's reader or owner, or its parent's owner. So in this case, the parent is of type drive. And then we go to drive, and then the owner is of type user. So one thing to keep in mind when you're building a hierarchy like this is that you want to make sure that the types of all of these things actually resolve down to the same type. So these are users, and anyone who has a view is ultimately going to be a user. So again, these are users, and this is a user. And that's it. So we've set up a simple hierarchy where we can actually federate out permissions by assigning a user as a reader or owner to the document, to the folder, to a containing element called a drive, and that's it. But this pattern actually is super common, right? It's not just folders and documents and users, right? It could be several things. It could be just getting rid of my detritus here. We could have these could be test results. And the test results could belong to a clinical trial. And a clinical trial could belong to a clinic who's running the trial. Or we could just say this is the administrator. Right? And we can set up that hierarchy between these things. These could also be, this could be a job requisition. And this could be a role that someone's trying to hire for. And the role could belong to a hiring manager. And the hiring manager could belong to an organization that's doing the hiring. So these kinds of hierarchies emerge in basically all of the use cases that we see. And it's really important because when people are first introduced to the concept of relationship-based access control, they say, that's annoying. I'm going to have to maintain all of these relationships between job requisitions and users, right? But what really happens is we often end up sort of normalizing the model where we don't have to add a user as the hiring manager to every job requisition. We can roll that job requisition up to a higher level resource, and then that resource is where we're actually doing the fan out between the actual users and the resource itself. So we can often normalize these models to reduce and to eliminate a lot of the relationships that it would seem like you need at the outset. That's it for now.